Well, it's Sunday and I've got 50 minutes before I need to get off for the next church service. So here we go with a Sierra Hotel 1 Tango set for Sierra Hotel 1 Tango Set Sunday, which we were doing a year ago, weren't we, in lockdown. We're going through a whole pile of great, that's great Taiwan, not great fantastic. So these have been very kindly sent to me by Mark, who sent me stuff before, and these are totally as a gift to me. Danita 3000 and Cobra 19DX4EU. I think we've had a look at one of these before, even if not on video, and I think they work better than those posy looking 29 things which look like a Cobra but don't work very well. And then here's the jewel in the crown as far as I'm concerned, the Barracuda GT868. And I've just spotted something which I didn't first spot when Mr. Chippy opened the parcel. Just put those down. I'm going to have to make a mic up. Yeah, I'll do some of that on video. So lots of the problems with the GT868s are that, yeah, okay, they're a bleed over box, but and they do 3.5 watts if you're good on a good day with the wind behind them. But there aren't that many people who can set them up, and there is the manual says the sweep generator method, and we've done that before, we've shown that. It's very time consuming going to the test points, but we've been doing this recently with the SINAD meter with excellent results. So we've eliminated the sweep generator. Now this has come from Texemco. Texemco, I don't even know if they're still there, but we're a UK firm of bulk repair, bulk modification. Supposing you got a product coming into the UK, and when the container gets opened, they discover that there's something not quite right, something which stops that product being sold in the UK. Perhaps the mains lead's got the wrong colour wires in it. So Texemco will come up with a solution, and they will process 5,000 modifications on a production line. And so when these were distributed by Halfords, the ones which were out of box failures went to Texemco for servicing. So you tend to find the ones with the Texemco sticker work better than the ones which hadn't failed. So it hasn't got the I thought the wires are going to be connected, but they're not, so that's fair enough. So put the speaker lid on one side. It's in lovely condition. So one of the first things we need to check, and if I find my remote control, is a resistor down here. I'll just get up and look at the monitor so I can see it. Oh, look! Can you see what I can see? That resistor. I bet this radio is doing about 0.5 watt on transmit because that's burnt out. So that's had a bad SWR, and that's what the result is. So there's nothing else there. Actually looks dodgy. Oops, helps if I put the camera back to its normal position, or you won't see anything. So to be honest, it doesn't look like it's had any work, it doesn't look like it's messed with. It's in lovely condition. Cliff and Connie's CB accessories. O1324, where's that then? No idea. So we'll splash some extra wire onto that and a fuse holder when the time comes. So the next thing I need to do was twofold. One, we may as well change that resistor, but I'll tell you what, we'll test it before. We'll put it on power. We'll see what watts it's doing before I do that. And then with the... Oh, that's the Amstrad 901 manual. What am I doing? What I want is the Fidelity manual, which is there. So I'll pause the video, I'll go and fetch a mic and we'll wire that up, because it's a unique wiring for great chassis. Okay, so here goes. So we've got this chart which I downloaded off the internet. We have another chart, but I don't know where that is at the moment. So this will do. It's got some hopeless errors in this, but this one seems to be one of the correct ones. I've just checked with the circuit diagram in the manual. Now, we've run out of blank microphones, so I'm going to, rather than not do this radio today, we will use one that's already got a plug on for Cybernet. We'll cut the plug off. We won't cut the plug off, we'll re-solder it. There's our jig, just to help us with soldering. Okay, with a precision screwdriver. I do get quite a few comments from people talking about wiring plugs and not understanding the terminology. It's going to be transmit TX, receive RX, COM common, as in ground, and audio, which is the actual microphone input. And so when you look at a chart like this, RX, TX, audio, common. And once you understand that terminology, hopefully it makes the job doable. So why won't this undo? We'll start it with a bigger screwdriver. I just slip these to one side rather than take both off. Then there's the teeny weeny screw. We'll pop that down. So that's as we are wired. So at the moment we've got yellow to pin number 1, and receive wants to be pin 1. So we'll unsolder the yellow. I'm going to tin that because they will have used that solder which doesn't have any lead in it, and we use 60/40 traditional solder and it works better for us. So that's the black one on these microphones. Black is the receive one, which is a pretty clever and sensible way to do it. Red's the transmit one, yellow's the audio, and your audio one is always the one which is wrapped by the screen, the screened wire, the common there. The screen is wrapped around that, so there's no signal loss. Also, it doesn't introduce pickup from things as well. It's a screen cable, but the screen only goes down that one lead. On these microphones, it's the yellow one. On some microphones, it's the white one. But whatever it is, you always know which the audio is because it's the one the screen is connected to. I'll tell you what we'll do. I mean, normally I'll be using that jig I got out, but I'll unsolder all of these. The trouble with the screen lead is, of course, it conducts the heat, so it's kind of a bit warm to work with. Just for now, we'll keep that red one connected, I think, or we'll. What shall we do? Executive decision. This currently goes to pin 4. We'll disconnect it. So we've got them all disconnected. I'm just going to run through this. Just a tiniest bit of the 60/40 solder. Okay. So I'd normally use the jig, but just so you can see what I'm doing, we won't. So we need to just identify the pins. So we'll put the black to pin 1. They are numbered. Pin 1, bottom right, with the ident there towards me. So I'll put the black one on there. Right, transmit, it says pin 2, and pin 2 is there. It says so. Audio is the top left one. And then finally we get to the braid, which is pin 4. So that can go back up there. We didn't use the jig. So what I tend to do is to load the teeny weeny screw onto the screwdriver and then hold it like that. And then of course I've now dropped the plug, so I've lost where the hole is. And then I can hold the whole assembly with the screw and line it straight up with the hole for instant insertion. So they've got a piece of sleeving there which we would need to put on if it was a blank. It isn't. If you don't put the sleeving, it's not just there for strain relief, it's also there because the clamp isn't kind of wide enough, and you'll end up with the cable coming out of the cord grip and the possibility of the wires pulling out. So there we are, rewired. We've got a mic. Plugged in, and these have the extension speaker socket, which some of the 858 models don't have. So we'll plug into the extension speaker socket. Power up. Last radio was doing was 12 volts, so I've moved us to 13.8. So I'll put picture in picture on. Don't know whether we're in high or low power there. So here we go. Power up the set. And you know what? I never did connect it up to the power supply, did I? This power supply is current limited at just under 2 amps. We're currently drawing 150 milliamps, and the radio is lit up. Oh dear. Oh, it's just sometimes your channel selector switch on all radios, when they've not been used for a very long time, can misselect to just dirty wafers. We've got a broken switch. PA switch is broken, so that's got to be sorted. What they've done is they've removed the wiring Oh, it's there. Yeah. So we'll need to look at a scrap chassis to see how that's wired back, because we want it to have PA. So if we're going to transmit now, there is no transmit. So I'll get my little onto receiver, transceiver. Testing 1 2, testing 1 2. So we know the radio is transmitting inside. So we've either got a problem with the PA, or it's quite simply that resistor is open circuit. So I'll have a look at the service manual. I can never remember which resistor number it is. The easiest thing would be for me to turn the power off and unsolder the pesky little resistor. But I'm so glad it's there, because it does save other things from getting destroyed. Especially if we can identify it on the other side of the board. I think it's there. I might be wrong, I might be unsoldering something totally unrelated. That's it. Now, because it's got so hot, I can't read what that says. You know what? The multimeter's in Mr. Chippy's domain, because I was doing something else. So it's resistor 65. So it should be 8.2 ohms at half a watt. So we'll use this. I don't normally use this for resistors. Yeah, well, it doesn't know what it is. It tried to read it as 12k there. So we know that that's more or less open circuit. Now, half watt resistors. Our standard range is 0.6. I think we've got a higher range here in these very expensive comp cards from Nova Electronics in Germany. We haven't got 8.2. Oh, these are 2 watt anyway. We don't want to uprate it, otherwise it wouldn't fail if it needed to. So what I'll do is I'll go and get an 8.2 ohm resistor from Mr. Chippy's department, where the comp card kit for those lives. So they're 0.6 watt metal film, but they're the size of 1/4 watt from a bygone era. So I'll just go and get that now. So I brought the multimeter back at the same time. So there's the new resistor. 8.2 ohms. So in comparison size-wise, you know, this is much smaller, but it is 0.6 watt. and hopefully it won't fall out. You look well if that's all that's wrong with it, though I can see a capacitor dangling out. There should be a tag just there, and that capacitor should go to it. So I don't know what that's about, but it's not. Okay, so we'll put the power back on. I think you know what, I think we're going to have to deal with this this wiring problem, because without that switch, how do I know that it's actually in the correct mode to even work at all? We've done that resistor, I've not got transmit, we should have transmit, and I think that's what we've got to do next. Now what I've got to do is try and find a great GT868 to copy the wiring. Just having a look around, there's a couple of 858s. I'll have a look on the shelf and see what we've got. So this is our working elf tone set, which I actually bought as a scrap chassis and then built up. So this is before we were doing the videos. And I can see the switch down there, and I think what we'll do is to write down the colours of the wires, because there may come a time when I don't have a set available to do this. So on my little stuffer sheet, PA switch, so it's PA CB. So with it towards me, so we've got 6 connections. Green, no connection. White, orange, yellow, and now is where the fun starts. Yeah, blue. That's it. So put that back together before it gets muddled up. Yeah, I bought a whole batch of scrap sets. I'm sure they came from Skegness off eBay about 18 years ago. You've got different batches, pile of scrap illegal sets, pile of scrap power supplies, we had those, pile of scrap UK sets, and I saw that this was in that pile of scrap sets still with the front on it, because most of them hadn't got fronts. In fact, I think this was the only one with a front. And anyway, I bought the batch and buckled down and sorted out the numerous problems with it, The case would have come off a scrap different radio. This is the ELCB 6000 Elf Tone, and he's featured on the Terry and June television show when Terry decided to buy a CB radio. So I think it'll be early 1982. I had a television in those days, but I haven't had a television since the year 2000, and I enjoy not having a TV license and having no inherent receive capability for television. So we need to get a switch from somewhere, and these are so ragged I think we'll cut them off. And that is going to be fab. We're going to have to take the front off and all that. So once again, I'll pause the video. What I've found is a scrap Eurosonic chassis in one of the storage sheds. It was a Euro 1 once. We'll have bought this like this. We don't scrap sets, and it's got a couple of rather, looks like they've been out in the rain switches, but I'm not that bothered about that. Perhaps we can clean it up a bit. What we're bothered about is whether it works. I don't think the toggle's quite as long. It is, you know, yeah, it is. It's just the way it's presented. It's not much different. I'd love to know where we could get these new from, but my source dried up probably about 5 or 6 years ago now, and we're left with no source. So it's a matter of when you come up against this, recovering them off a scrap chassis, which is why we buy scrap chassis in. Just hope this is going to fit. That's another problem. So before we wire it, we will just check that it fits. So because of that, we'll just cut the wiring off. Just take that bit of shrouding off for now. Yep, the two nuts which have been glued onto these actually, it's a strange way of doing it. Certainly fit. See if we can pull the wiring off for this. I think Mark said he bought, a mate of his bought these off eBay in the hope of him either fixing them himself or something like that, or finding one in the batch that worked, and of course none of them work, and without some test instruments you can't fix them yourself. Now theoretically, if we were doing this for a customer, we would actually unsolder everything and feed all the wires through the holes properly. That captive nut's fallen off, so perhaps they're being used as a spacer, which isn't necessary in this application. So the question now is that the correct thread? Seems to be. So I think in this application it was just being used as a spacer. So we'll remove the other one, which was easy to do. So what they am, 3.5. Now, whether or not these are all long enough is another question. Should have 5 wires, and we have got 5 wires. The first thing we'll test when we get this back together is if it works in PA mode, and that's a really useful test when sets have got PA. It proves that the receive audio amplifier is working, and it proves that the microphone preamplifier is working, so it's really good. So although it's pretty pointless, most people having public address facility, it's a useful test thing. Right. Now, this one, this replacement switch, has the end connection cut off. So I'm now going to wire this backwards to take that into consideration. So instead of it going orange, white, no connection, we will have it orange, white, no connection. There we go. So looking down, like we did on our notes here, we should have no connection, white, orange. Well, that's now on the other pole. No connection, white, orange. Then on the other pole, it's green, yellow, and blue. And although it makes absolutely no difference, it can be confusing to somebody who has to repair the set in the future. So we'll mount that. We know it's green to the top of the radio, so pop that down there. Just look which switch it is. So it's the one there. There we go, that's screwed in. And we'll put that little shroud back on so that the works doesn't show through the front panel. I won't put the front panel back on, it's tight enough without pushing it around. So we'll see what happens. We'll put this back. We'll put this now into public address socket. Plug the mic in. Switch the power on. It's one of these. Why isn't mic gain doing anything? It's the right hand one, I thought. Oh, it doesn't have mic gain, does it? Well, that's really clever. You can't control the volume. Anyway, it works. Because it's not done on the volume control, it's done on mic gain control on sets with mic gain, but it hasn't got mic gain. So if you wanted PA, you'd actually have to use one of those dreadful power mics and then adjust the gain on that. Oh, hang on a minute, am I in the wrong position? No, that's CB. So now the radio key's up. So it was the PA switch which was broken. That was the second reason there was no transmit. So that's full power, that's low power. So here goes. Let's go through it. First of all, we'll see if it's on frequency. No, so we need to address that, but we'll do that in a moment because I'm going to have to take the shield plate off. So transmit is L207, 5, 6 and so on up the sequence. So at the moment, what power is it doing? And the answer is 2.5 watts. Now anything over 1.7 watts is acceptable. So don't think if you've got a radio, one of these that's doing 1.7 watts, that it's faulty. It isn't. That is the cut-off point. I have seen 4 watts out of these, but they are sold as a 3.5 watt radio. So don't think they're supposed to be 4 because they're not. So here we go. Maximum. Maximum. I couldn't see the display. I turned the dimmer down. I can hear you all talking to your computers. Yeah, it's dim like you. L8. So we're now at 2.9 watts. If you've got a coil down there in that compartment, that is the 54 meg second harmonic trap, which you don't want to be adjusting without a spectrum analyzer. Well, it's taken us over 3 watts, so we'll change scales. 3.3. That is determined, that wire. Let's warm that up a bit. And this is one that's doing 3.9 watts. It's just a whisker away from 4. So if the radio cooled down, the good news is it's only drawing 970 milliamps. So, you know, lots of new sets which will draw more than 2 amps. It's very efficient. 3.9 watts, can't be bad. So one of the things we can do while we're at it is the preset there is for the RF meter. I can't now see where I am, that's it. So key it up. Actually supposed to be in the centre of the red zone. And you always set it for centre of the red zone. It's not something that's calibrated. You know, if the transmit was only doing 3.2 watts, we'd still set it for the centre of the red zone. Otherwise people don't think they're transmitting. It's psychological. Which is of course better than the current sets. 9 out of 10 of them have fake meters which put a lovely bar graph across but actually aren't connected to anything and is a glorious TX light. So I'm actually very pleased with this, and you know, somebody scrapped this for want of a PA switch and probably not knowing about the resistor that can fail. So let's look at transmitted audio. So we'll stay on the same scale with you, and it should be 2.2 to 2.5 kilohertz. Wallow, it's too high. So just pop that down again and it's there. We'll try it at that point. Wallow, testing 1, 2, wallow. That's about where we want it. Well, that's transmit sorted. I'm looking at the time. I'm going to have to push off very shortly. And we'll go over to receive and just see if we actually have any receive at all. It's 2779125 on the signal generator. I can just hear that. I'll just turn the radio off and we'll just take this shield off and deal with the frequency. So here we go, onto the frequency display, and we need to be adjusting, I think it's CT201, yes, CT201, and CT201 is this one here in the naughty corner, because you've got others which affect the VCO. It's quite a complex synthesizer. It's a general purpose synthesizer, so it uses a different technique to if you had say a 7137 LC7137 or a Toshiba TC9119, which are pre-programmed. These aren't. It's a high quality trimmer capacitor, and so we shouldn't have any problems with that. There we go, 79125 toggling 6. That'll do nice. I'll keep that lid off just in case. So let's look at the sensitivity before we start. So I've put it on frequency. Let's squelch, it's RF gain. So before we even start, it is doing 0.81 microvolts. 0.81. Where's a scrap of paper? There's never a scrap of paper when you want it. So using the SINAD meter method, we're going to go through all these receive. Well, that's an improvement. Put a bigger signal on. Check these again. Then the detector ones, which are Sh1t set up from scratch. Like that was out, wasn't it? Let's go back to that one. That's livened it up a bit. So let's see what we've got now. How about 0.32 it shows on that scale. And on the next scale up, it actually shows 0.295. So I can safely say this is going to be about 0.3, 0.31 of a microvolt for 12 decibel SINAD. You know, there's no arguing over that. Excellent. These radios are only about 1.5 watts of audio output, so any of you with great big diesel engine lorries, you're going to need an amplified speaker. Okay, let's see where the S meter is. So we don't use the oscilloscope on this, it's a different type of detector. The squelch is AM squelch, so there's an AM detector, that's what does the squelch. We'll come to that in a moment. So right now we're going to do the S meter. So for a CB in the UK, not for a ham radio, for a CB in the UK, it's S9 equals 100 microvolts. So it's the one there. It's reading a bit generous, so we'll just pop that down. To there. So that's that set. Now the squelch. Just going to put the squelch to full, and we'll see when it comes in. So here goes. I'll put this onto there so you can see it. So at the moment we're up to 0.3 of a microvolt, 1 microvolt, 3 microvolts, 10 microvolts. I want this to come in at 100 microvolts, so it's S9 equivalent. 30, 100, it's spot on. Absolutely how I want it to be. But if it wasn't, the squelch is adjusted with the preset just back there. The low power on this radio, on transmit, we'll just go back to that. Low power is 290, 300 milliwatts. It's supposed to be 400 milliwatts, it's non-adjustable. It's of course absolutely pointless changing resistor values to try and mess about with that. It's just as it is what it is. So we're actually done as far as the radio goes, and I'm going to go and do this church service, and then we'll put the front back on. I'll try and clean that that knob on, that switch on I've put on, and we'll take it from there. So I'll see you in a couple of hours. Okay, so I'm now back from church. I've put the front on. There's enough lugs. There's two on one side and one on the other. Top and bottom ones are broken on the case. People over tighten these, and that's what breaks the front usually. It's not just great sets; it also happens on certainly on the Cybernet ones as well. So let's hope that speaker works. That can be the only thing now which could be holding us up. Just re-tin these. Yep. Plug the mic in. And that makes up the earth. So we want some screws. The radio didn't come with any, but we happen to keep new screws in stock. And let's hope that the screw holes haven't had incorrect screws forced into them. You know what? I've not put the screen cover back on. I'll just put that screw there. Tighten those up later. I saw it grinning at me. Turn it off just so we don't inadvertently short something out. I've been through full alignment of these with you before on other sets where the VCO has been messed with, but on this occasion there's no reason whatsoever to go in there except to put it on frequency. The other thing it's useful to do, because you can end up with a bit of a microphony problem, is to solder the lid to the other lid. Black M3 machine screws are readily available either through the usual trade electronics houses like Farnell and RS and Rapid Online, and of course with eBay for smaller quantities. So there's no excuse to have wrong screws really. Work out about 6p each. Makes me wonder when this last worked with that PA switch problem and the resistor as well. So we'll plug an aerial in, turn the test set off, may as well put the squelch to somewhere. One niner, Roger. Thank you. Sunday at 5:30. It's about the liveliest we've ever had, isn't it? So jolly good received. Did I say 0.31 of a microvolt? I think it was something like that. Very good. So we'll do a test with Mr. Chippy, and there you have it. Yeah, loud and clear. Break for the rig check. I don't think he or she heard me. Okay, so there we have it. Barracuda GT868 from 1981, using the great GT868 chassis, of course. Thank you for watching.